Now we would like to run some simulations to predict the behavior of our gene regulatory network in silico. That is as simple as going on simulation run. But if we do that, we end up with an empty graph because we have not specified what we want to simulate. To do that, we go on simulation settings, and the upper tab allows us to select which species we want to follow over time. In most cases, we are interested in the protein products of the node. So here I will select PN1, PN2, and PN3. Save and close. Also important is that our representator at the moment is perfectly symmetrical, meaning that all three nodes are identical to each other, and the initial amount of all these nodes is set at 0. Under these conditions, we will not observe oscillations as expected, so we want to introduce some asymmetry in the system. In particular, we want to make the protein product of one of the three nodes non-zero. This will be the node that kickstarts the oscillation. We've seen how to do that in the previous video. We can simply click on a node, go on set, and change the initial amount of that protein product to be 500, for example. And now we can run again our simulation. And we see that something is happening, but it looks like the time window we are simulating is too short. To increase that, we go again on simulation setting, and we can change the stop time to be 1440, which equals to 24 hours. Save and close, and run again our simulation. So now we see oscillation of the three protein products over time, represented in blue, red, and yellow respectively. In case you want to change the unit of time that is currently set in minutes, you will need to modify the node model code. Let's see some of the other features that allow user to customize their simulation. We go again on simulation settings, and we see, for example, maximum wall clock. This sets an upper limit to the simulation in case we are worried the computation is going to take too long. While stop time unit is minutes and it is described at the node model level, maximum wall clock is built in your computer and it is always in seconds. So now it is at 10 seconds, and it will simply abort the simulation if it takes longer than that. This feature can be interesting, especially when working with stochastic simulations, because some solvers can be rather slow. Then we have absolute tolerance and relative tolerance, which are measures of the accuracy of the simulation. The lower the tolerance, the higher the accuracy of the simulation. But keep in mind that there is a trade-off between accuracy and computation time, meaning the higher the accuracy of a simulation, the longer it will take to perform it. So you might want to start with relatively large tolerance at first when we're still exploring and tuning our circuits, and then once we're happy with the topology and the parameters, we might repeat simulations with lower tolerance. Also, we might want to lower the tolerance whenever we observe interesting or unexpected results, to really make sure that these are not due to low accuracy of the simulation. Then we have some interesting features that are imported from SimBiology. But before we look at them, let's have a look at SimBiology itself. If we click on simulation, open in SimBiology, we are redirected to the MATLAB SimBiology page, where we can explore our model. We see the species that compose our system, the parameters with all values, the equations of our model, and the reactions of our system, alongside with many other tabs and functionalities. SimBiology allows user to run their models, feed parameters, perform sensitivity analysis, and much more. In case you're curious about the potentialities of this toolbox, you can head over to the MATLAB page of SimBiology, where you will find plenty of information. Okay, let's go back to our simulation settings to describe the SimBiology built-in function. We have dimension analysis. So these will basically check all the equation of our model to make sure that the units of the parameters match and make sense. If not, it will abort the simulation. So if we have used the basic functionalities of the app, normally everything should be fine. But at times it happens that we need to specify new parameters, and it might not always be straightforward to assign the appropriate units. Let's give an example. Let's say we have an external inducer, such as light, that activates one of the nodes. And we decide to make this light pulse oscillating over time. So we have an extra element, an extra parameter that is not fixed throughout the simulation, but needs to change over time. To describe that, we need an extra rule. So we select our light parameter, and we can use a function. This could be any MATLAB function, in this case SimWave, to describe this parameter. Sometimes when using these rules, you might need to specify new parameters, and in that case you should also specify the unit, which you can take from some of the existing parameters. And as said, it might not be super straightforward to assign the correct unit. So in case you're uncertain, you might want to uncheck the dimension analysis box, because this might simply abort the simulation in case it finds something wrong with the parameter units. Finally, we have the accelerate box. If you check accelerate, it will take a bit longer to run the simulation at first, but then it will be much faster to play around with parameters later on. Keep in mind that for accelerate to work, you need an appropriate compiler that is C++ compatible. And again, if in doubt, head over to the MATLAB page, supported compilers, which will help you find the appropriate compiler.